Hi, Stu Schwartz from MasterMathMentor.com. This is video AB18. Our topic is 3 important theorems, and it covers the AB manual pages 103 through 105. Hi, Stu Schwartz. In this video, we look at 3 important theorems that are called existence theorems. An existence theorem claims the existence of a solution to a problem. It does not necessarily detail that solution, just that its solution does exist. Existence theorems are very important in a real-world sense. For instance, imagine a golfer attempting a putt. As you can see on the right, the ball is perched at the edge of a steep slope, and the hole is at the bottom of the slope. The putt is very difficult because of the danger that the ball will have too much momentum and roll over the hole. Even if the golfer just taps the ball very slightly, it may have so much momentum that it will roll over the hole. If a pro golfer claims that there exists a way to make the putt, another golfer could confidently try the putt over and over again with the knowledge that he can make it if it is struck perfectly. However, if no such claim were made, it is possible that the golfer would continue to try to make a putt that really is impossible to make. As a teacher, many students over time who have solid B averages have asked me whether there is a way that he or she could get an A in the course. That, in a way, is an existence theorem. The teacher's answer will impact how much the student studies for the final exam. If the teacher says that there is no possible way to get an A, then the student may not study that much. Our first existence theorem is called the intermediate value theorem, or IVT. You may have learned this in pre-calculus. It states this: suppose that f of x is continuous on the closed interval AB, and let m be any value between f of a and f of b. Then there exists a number c such that c is between a and b, and f of c is equal to m. The intermediate value theorem says that a continuous function will take on all values between f of a and f of b. To the right is a graph of a continuous function that illustrates the intermediate value theorem. As you can see from the graph, if we choose any value m between f of a and f of b, and draw a straight horizontal line out from this point, the line will hit the graph in at least one point. In other words, somewhere between x is equal to a and x is equal to b, the function will take on the value of m. Also, as the figure shows, the function may take on the value of m at more than one place. In this case, there are 3 values of c, C1, C2, and C3, such that f of those c values is equal to m. Hi, Stu Schwartz. In number 1, we were asked to show that f of x equals 2x cubed minus 8x squared plus 5x minus 2 has at least one root between x is equal to -1 and x is equal to 4. F of x is a polynomial, and f of -1 equals -17, and f of 4 equals 18. So the intermediate value theorem holds. There must be at least one value of c between -1 and 4 where f of c is equal to 0. Hi. 2 asks, does the IVT guarantee roots for f of x equals 5 cosine of x plus pi sine of 3x minus x on the open interval 0 to pi? The cosine function is continuous and the sine function is continuous, so their product will be continuous. f of 0 equals 0, f of pi equals negative pi. So we cannot determine whether there are values of c on 0 to pi where f of c is equal to 0. One of the f values must be positive and one must be negative to determine whether there are roots. In fact, if we graph this, we will find that there are two, but the intermediate value theorem is of no help. The intermediate value theorem has some obvious but practical applications. For instance, if your height when you were born was 20 inches and now you are 6 feet tall, your height must have been every value between 20 inches and 6 feet in the time you have lived. If you are traveling at 100 miles an hour and a policeman makes you stop, you have to travel at every speed between 100 and 0. You may do it in a very short period of time, but you will go at every speed between 100 and 0 because of the IVT. But if a phone costs $599 when it first went onto the market and now is selling at $399, it does not necessarily have to have cost $450 at some point between those two times. The reason is that price is not a continuous function, and therefore the intermediate value theorem does not hold. Using the IVT can fix a wobbly table. If your table is wobbly because of an uneven floor, just rotate the table. Why? We can always have 3 legs on the ground. It's the fourth that will cause the trouble. If the floor was like sand, so that the leg could also go into the ground, we could rotate the table so that at some point the fourth leg will be above the ground, and at another point it will be below the ground. So by the IVT, there must be some point where the fourth leg perfectly touches the ground. Hi, Stu Schwartz from MasterMathMentor. Our second existence theorem is called Rolle's theorem, named after Michel Rolle in 1691. Unlike the IVT, it uses calculus. Formally it says, let f of x be continuous on the closed interval AB and differentiable on the open interval AB. If f of A equals f of B, then there must be at least one number c in the interval AB, such that f prime of c is equal to 0. Informally, it says that if we have a differentiable curve between two values of the same height, there must be at least one point in between where the tangent line to the curve is horizontal. We see that in the graph. We have f of x in blue, and notice that there are two values, a and b. And f of a is equal to f of b, as shown by the horizontal red line. So there must be at least one value between a and b where the tangent line to the curve is horizontal, as shown by green lines. In this case, there are two, but there must be at least one by Rolle's theorem. So an even more informal way of describing Rolle's theorem is, what goes up must come down, and what goes down must come back up. Hi, Stu Schwartz. In problem 3, you are to show that Rolle's theorem holds between the two x-intercepts of f of x equals x squared minus x minus 12. First, we must find those x-intercepts, and we factor f of x into x plus 3 times x minus 4 equals 0, and x is equal to negative 3 and 4. F of x is a polynomial and thus differentiable, and therefore Rolle's theorem holds. So we take the derivative of f and get f prime of c equals 2c minus 1, and therefore if we set that equal to 0, c is equal to 1/2. So when c is equal to 1/2, our point is 1/2 negative 49/4, and our tangent line is horizontal. This can be confirmed graphically by graphing f of x and examining the point 1/2 negative 49/4, and the tangent line appears to be horizontal at that point. Hi. 4 asks to find all values between the non-zero x-intercepts for which Rolle's theorem holds on the function f of x equals 3x squared minus x to the 4th. We first find those x-intercepts by setting f of x equals 3x squared minus x to the 4th equal to 0. That gives x squared quantity 3 minus x squared is equal to 0, and x is equal to 0 and plus or minus the square root of 3. We are interested in the non-zero values, so we use plus or minus the square root of 3. F prime of c equals 6c minus 4c cubed, which is 2c quantity 3 minus 2c squared is equal to 0, getting c is equal to 0 and plus or minus the square root of 3/2. All three values are inside plus or minus the square root of 3. So there are 3 points where the tangent line is horizontal. 0, 0, the square root of 3/2, 9/4, and negative the square root of 3/2, 9/4. The red graph of f of x confirms the 3 points of horizontal tangency. Hi, Stu Schwartz. 5 asks to find the value of c guaranteed by Rolle's theorem for f of x equals 4 over x squared minus 9 over x on the interval 1/2, 4. In order to use Rolle's theorem, you must make sure that the rules for Rolle's theorem are met. One of them is that the function must be differentiable. F of x is not differentiable at x is equal to 0, but the interval that we are concerned with is 1/2, 4. And since f is differentiable on the open interval 0 to infinity, we can apply Rolle's theorem here. Secondly, we must make sure that f of 1/2 is equal to f of 4. F of 1/2 is 16 minus 18, which is negative 2, and f of 4 is 1/4 minus 9/4, which is also negative 2. So Rolle's theorem is set to go. Therefore, f prime of x is equal to negative 8 over c cubed plus 9 over c squared, getting a common denominator that is 9c minus 8 over c cubed, which has to equal 0, and therefore c is equal to 8/9. A graph or the point of horizontal tangency was not required, but I give it here. The point is 8/9, negative 5.0625. And that point certainly appears to have a horizontal tangent. Hi, Stu Schwartz. Our third existence theorem is called the mean value theorem. It's a theorem that you probably never heard of in terms of its name, but you probably understand its implications without studying it. We use an example. 2 police cars are located 5 miles apart on a long straight road. The speed limit is 55 miles per hour. A car passes the first police car traveling at 50 miles an hour. And then 4 minutes later, that car passes the second police car still traveling at 50 miles an hour. The question is, can the officers issue the driver a speeding ticket? To answer this, we calculate the average velocity, which is total distance over total time, or 5 miles in 4 minutes. We multiply that by 60 minutes over 1 hour and get 75 miles per hour. So, if the driver averaged 75 miles per hour, at some time in that 4-minute time period, that driver must have been traveling at 75 miles per hour. So yes, that driver was speeding. Whether the officers can issue the driver a speeding ticket based on this evidence is up to the state in which the car was traveling. Hi, Stu Schwartz. The mean value theorem, abbreviated MVT, states this. If f is a continuous function on the closed interval AB and differentiable on the open interval AB, then there exists a number c on the open interval AB such that f prime of c is equal to f of b minus f of a all over b minus a. This says that somewhere between a and b, there is a point c on the curve where the tangent line at c is parallel to, meaning has the same slope as, the secant line to f between a and b. Let's show that graphically. We start with the differentiable function f of x, and x is equal to a and x is equal to b. So we show the points a, f of a, and b, f of b. We next draw the secant line between the points a, f of a, and b, f of b, and calculate its slope, which we know to be f of b minus f of a over b minus a. Hi, what the mean value theorem says is this. There must be some value c between a and b, such that the tangent line to the curve f at the point c, f of c, is parallel to the secant line between a, f of a, and b, f of b. That means that the two lines, the red line and the green line, have the same slopes. Or f prime of c is equal to f of b minus f of a over b minus a. Hi, Stu Schwartz from Math. On number 6, you are given f of x equals 3 minus 5 over x. In your manuals, you are asked to draw the secant line between x is equal to 1 and x is equal to 5 on the graph, and then draw the tangent line at the value of c, which you believe to be the conclusion of the MVT, without doing any calculations. Then actually use the mean value theorem to find c. Our function is differentiable except when x is equal to 0, so the mean value theorem holds. It says that the derivative, which is 5 over c squared, is equal to f of 5 minus f of 1 over 5 minus 1. So 5 over c squared is equal to 2 minus negative 2 all over 4, where c squared is equal to 5. That makes c equal to plus or minus the square root of 5. But we are interested on the interval 1 through 5, so our c value is equal to the square root of 5. We confirm the results graphically. The red line is the secant line, and the green line is the tangent line at c equals the square root of 5. Hi. In number 7, you are asked to find the equation of the tangent line to the graph of f of x equals 2x plus sine x plus 1 on the interval 0 to pi at the point that is the solution of the mean value theorem, and to confirm by calculator. Our curve is certainly differentiable. So the derivative at c is 2 plus cosine c is equal to f of pi minus f of 0 over pi. And that leaves us with 2 plus cosine c is equal to 2 pi plus 1 minus 1 all over pi, and we get cosine c is equal to 0. So the point of tangency c is pi over 2. F of pi over 2 is pi plus 1, which is pi over 2, and f prime of pi over 2 is 2 plus cosine of pi over 2, which is 2. So we have enough for our point slope formula. The tangent line is y minus quantity, pi plus 2, is equal to 2, quantity x minus pi over 2, and y is equal to 2x plus 2. If you have the time to confirm these types of problems graphically, take it. It will make you feel good that you've got the right answer. We see in the graph the function in blue, we see the secant line in red, and we see the tangent line tangent to the curve at the point pi over 2, pi plus 2. The green line certainly looks parallel to the red line. Hi, Stu Schwartz. 8 is a problem that is primarily solved using your calculator. We would like to find the value of c that satisfies the mean value theorem for f of x equals 2 cosine x plus cosine 2x on the interval 0 to pi. The cosine function is differentiable, so the mean value theorem holds. F prime of c equals negative 2 sine c minus 2 sine of 2c. And that will equal the slope of the secant line, which is f of pi minus f of 0, which is negative 2 plus 1 minus the quantity 2 plus 1 all over pi, and that is equal to negative 4 over pi. So we have the equation negative 2 sine c minus 2 sine of 2c equals negative 4 over pi. This must be done on the calculator, so we graph y equals negative 2 sine x minus 2 sine of 2x on the interval 0 to pi, and also y equals negative 4 over pi on that same interval. And we see that there are 2 points of intersection at 0.217 and 1.748. So those are the values at c that satisfy the mean value theorem. If you have the time, it certainly is satisfying to verify your solutions. We see in blue the graph of our function f of x equals 2 cosine x plus cosine 2x. And we see in red our secant line between x is equal to 0 and x is equal to pi. We then draw our tangent lines at c equals 0.217 and c equals 1.748 in green. And we see that they appear to be parallel to the secant line in red. It seems that our two answers are verified.